Ranger Amy, and today we're going to talk about soil. As a forest ranger, we have to monitor the soil to make sure that it's healthy so that we can grow healthy trees. We can take care of the environment where the trees live and the forest, and the animals benefit from healthy soil as well. Soil helps trees grow, and as you can see in our example here of a little mini willow oak, there's lots of roots in the soil. The soil has different colors, and this tree seems to be really happy and healthy. It's nice and green. And we're going to talk about some of the interrelationships between soil and plants and their survival. We're going to talk about how the different characteristics of soil, including structure and texture, plays a role in how much water can stay in that soil or drain quickly or slowly through that soil. And we're also going to go into the forest and we're going to take a soil sample, and we'll also compare it with a sample in a grassy field. So what is soil? When I was your age, my parents told me that dirt was what I found underneath my fingernails, and soil is a living, breathing thing. It's the skin of the earth. It provides space for plants to grow. Think about all the plants in your yard and the plants in the forest and in your garden. It provides a space for nutrients and water to be stored. It filters the water, and it allows us to have healthy trees, and we turn those trees into forestry products. We can get food from those trees. We can get food from the plants in your garden, and it is comprised of roots and air and mineral resources and organic material. And we're going to talk about how soil is formed. So there are 5 main factors that create the formation of soil. And the first is the parent material. And parent material is like bedrock. And it can be weathered chemically or physically. So an example of chemical weathering is a chemical reaction like rusting or oxidation. And physical weathering is mechanical change like gravity or wind or water rushing over the rock, and either one is breaking the bedrock down into smaller and smaller pieces, and that helps to form the soil. Then we have climate, and that's about the type of weather where the soil is and if it's hot or cold for longer periods of time during the course of the year. Warm, wet weather is going to create soil faster than cold, dry weather. And then you have the organisms that live in the soil. All your decomposers that you might think about, your worms and your little decomposing bugs and beetles, and the microorganisms that you might find. Like here's a really good example of decomposing mulch, and that will help to build soil as well. And then you have relief, which is like if you're on the top of the mountain, you may have less soil than on the bottom of the mountain because of all the gravity that's pushing that soil down the bottom of the hill. At our forest, Holmes Educational State Forest, we have lots and lots of nutrient-rich soil at the bottom of our mountain. Therefore, we have a lot more plants that are growing nutrient-rich soil, and there's a biodiversity of plants that are at the bottom of the mountain because of the relief that makes the soil. And then time. So again, if you're building soil from the top and you're using decomposition and you're out in the forest and you have broken down leaves and needles and that's making topsoil, that's going to take way less time than chemical and physical weathering that's breaking down the parent material, which is the rocks. So as forest rangers, we're interested in the properties of soil because it helps us understand what plants can grow best in that environment. Builders are interested in the types of soil because they can figure out what they can build on that piece of property. And every county has a soil survey, and here's an old example of a soil survey. You could get a book of your county, and inside of the county it has all the different types of soil. But a modern way to look at your soil information on your property is to go to the Web Soil Survey. Here's a little example of what you might find. And that tells us the name of the different soils on our landscape, and it tells us the texture and structure. Now, what do I mean by texture and structure? What I mean is how much clay, sand or silt is inside of that sample of soil. So there's three main particle sizes that we look at when we're taking a soil sample, and the first one is sand, and that's the largest particle size. And when we take a sample of it, it feels granular like sandpaper. It's a little bit soft. Think about when you go to the beach and you build a sand castle and you dump water on top of that sand castle. The water just kind of flushes right on through. The water retention capacity for sand is not very good. The next one is silt, and this is a lot smaller particle size, so it's going to hold water just a little bit better. It's soft to feel, and again, it's medium size in comparison to the three. And then clay is the tiniest particle size, and because those particles are so close together, there's not that much space in between, and it has the ability to retain water a lot better than the other two. So if we're thinking about the size, there's a couple ways we can think about. If you were in a group of people and you were a sand particle, this would be the space around you. If you were silt, this would be the space around you. And if you were clay, this would be the space around you. And think about how water could pass through because of the space around you. Another way to think about it is the particle sizes in this container here. You have a basketball, which is your sand, a golf ball, which is your silt, and a marble, which is your clay. And if we were to fill this container up with all basketballs, think about the space that would exist between all the different basketballs. Therefore, the water could pass through pretty easily. If we were to fill it up with marbles, they would be so packed and close together that the capacity to hold water would be even better than the sand. So when we go out and take soil samples in the forest, there's two tools that we use to take those samples. We have a soil probe and a soil auger. The samples that they give us provide us information about the soil profile, which you can see over here. And the profile has different layers in it. And the space between the layers is important for us to know, and the contents in those layers is important for us to know as well. So again, here's an example of a soil sample that was taken 2 feet down, and here's a soil profile. And the different layers that you might be familiar with are, well, the first one is the organic material that's on the top of the ground. Think about when you walk around in the forest and you see the leaves and the sticks and they break underneath your feet. That's called litter. That stuff fell down this year, last year, and it hasn't really started decomposing yet. And then you get a little bit further down, and that's the duff. And duff has started to break down. It's maybe last year's leaves or last year's sticks, and those decomposers are starting to break it down even further. And we can recognize what it looks like, but not quite. And then you have humus, and that's the beginning of the topsoil. And that's where you can't really even tell that it was a leaf or a stick. It's gotten to the point where it's a darker color, and it's looking about the same in consistency. And so that's the first layer. We call that the organic layer. Then the next one is the ahorizon. Other people call that the topsoil layer. And think about when you're in your garden and you want that rich, dark topsoil so that you can have healthy plants. It's the same in the forest. The A layer there's some nutrients. There's lots of roots. Here's an example again of the A layer, where you have the roots and the nutrients that are present for the plants to grow. And then the B horizon, this is where leaching takes place. This is the subsoil, and you can see that there are a lot of roots in the subsoil. The minerals that we have, like phosphorus and nitrogen and potassium, those are present in this section of the soil, and they're actually leaching down with gravity as time goes on. And then the C horizon is where we're going to see some of those materials that recognize from the bedrock material, the parent material, the smaller particles that have filtered down from the topsoil. So that's our horizon there. And when we take samples, we're interested to know the depth, how much space is taking place, how far away it is from the bedrock, and that helps us determine what plants can grow there, and if we're building, how we can build objects on that ground. But if we think about the horizons in another way, I like to think about it as a pizza, just like we have layers on a pizza. So the parent material, the smaller particles, we can have that be our crust. And the subsoil, the B layer, where the leaching takes place, that can be our sauce. And then we have the topsoil, the A horizon, that can be our cheese. And because there's so many different layers in the organic material up here, we have last year's leaves and this year's leaves, we can add some different toppings. So the humus can be the pepperoni, the duff can be our peppers, and the mushrooms can be our litter. So that's another way to think about the horizons and the building of the soil from the top down. Our two soil samples here, the one from the auger and the one from the probe, we took this in a grassy field. So we need to consider the history of the landscape when we take our soil samples. We'll talk about the history here in a minute, but let's talk about the horizons first. So right here is the organic material. You can see again, there's some living things and then there's some non-living decomposed objects there. You can start to see the humus layer. And then it's hard to tell where the A horizon and the B horizon start and stop in this particular example. But it's possible that we didn't even get to the B horizon and this is just all the A horizon. But can you see there's a break right there? Maybe that's the topsoil. We're going to take that between our fingers and just kind of feel. And remember I was telling you about clay? The more clay that you have, it makes a ribbon when you're pushing it between your fingers. The color of the soil sample also gives us some nice information. Here's some organic material. There's some rocks in this sample, as you can see. It's kind of crumbling away, so maybe there's more silt and sand. And then again, we can take this sample as well. It was harder to see where the A horizon was, but it's kind of right here, the topsoil there. But why do you think that the depths of these samples was so shallow? I have an observation that this is a grassy field and we use our lawnmower to mow the area. Therefore, the soil is compacted and the pore space between the particles has been pushed together by the weight of that machine. Maybe it's compacted, so that's one thing. Another thing is that we're close to a road, and this is a forest that has active forest management. So it is possible that the sample area used to be a road, or we moved the earth in some capacity to get to the trees in the forest, and therefore that it has some human activities, some history of humans moving the landscape a little bit. There's some rocks, maybe some gravel from an old roadbed there. So taking soil samples sometimes tells us about the history. Maybe this isn't a good example of the soil layers, but it is helpful to understand what happened to the landscape in the past. Let's go take another sample in the forest and see how this soil sample is different. So here we are in a deciduous hardwood forest, and you look around and the trees seem to be pretty happy. They have plenty of nutrients, water, and space to grow. But let's look down here at the forest floor. And we can talk about the organic material that we're looking at right here. And these are the components that make up that first layer, the organic layer of our soil profile. So the first thing that we're going to see is some of these sticks that are starting to decompose. You can see some of the cells that are breaking down and they're starting to rot. So you have the sticks maybe fell down this year, last year, even the year before. And then we have some leaves and needles. And again, like I was telling you about the duff has started to decompose, but we can still tell that it's a leaf and a needle. And we're going to take a even larger bite here. And again, here's some more that decomposed. It's partially decomposed, but we can still tell what it is. And then look at this nice dark mat of roots that is right here, and you can start to see the roots, and this is the humus layer. We can't really tell now that those are decomposed leaves and sticks and needles. It all is pretty consistent in shape and size and structure. So this is our humus, beginning of our topsoil, and we can use a shovel to kind of get even lower down there. Nice root mat. Lots of nutrients right here. And then here's our topsoil layer. And it feels granular to me. I can't really make a ribbon with it, so it has more sand in it, maybe more silt than clay. Oh, check this out. We have a decomposer that we found in the organic layer here. Regular earthworm. Whoops! And of course, he's part of, if we were asking ourselves if he was a decomposer, a producer, consumer, of course he'd be a decomposer. He's gonna break down that organic material. That's a nice find. Think about some of the other microorganisms and fungus, bugs, and other organisms that live in this layer that would help to break down the soil. So when you're taking the sample, sometimes you have to break through the roots, but because we're in a lush forested environment, it feels like the topsoil is pretty dense here, and it's a good spot to take a sample. And you can see that the soil color changes. So we have the organic and the A horizon. And then as the color changes, we're starting to get into the B horizon here. So in this lesson today, we talked about how soil provides the nutrients and the space for plants to grow and keep the forest healthy. We talked about the 5 factors that make soil: weathering, climate, the relief, time, and the organisms that make that soil. The components of the soil: 45% minerals, 5% organic material, 25% water, and 25% air. We talked about how the structure and the texture is the way that it feels, and the structure is the shape, plays a role in how much air and water can be in that soil and held in that soil. We talked about the horizons and how it kind of looks like a pizza, and the organic material is on the top, and that helps to build the topsoil. And then you have remnants of the parent material. We talked about the size of the particles. Sand is the largest one, silt is in the middle, and clay is the smallest particle size. One other thing we can think about is the pH, how much acidity or alkalinity is in the soil, how sweet or sour that soil is, and that helps play a role in what plants the soil can support. Like, for example, blueberries like really acidic soil, but most plants like neutral soil. And all of these factors of soil help us understand what that environment is like, what plants can be supported in that environment, how much water can be retained and stored in the soil, how much water is going to be filtered quickly through that soil, And by learning about the soil in our forest, it can help us support the plants that live in this forest as well.